If you look up into the sky, you can't see the Earth's magnetic field because it is invisible to human eyes. But it's there, and just because we can't see it, it doesn't mean it's not important. It protects the planet from harmful blasts of solar radiation and cosmic rays. But the magnetic field has been doing some very strange things lately that have taken scientists by surprise. It's moving almost 4 times as fast as normal towards Siberia, and researchers are scrambling to understand why. Could there be a big problem, and what consequences could it have for us and the planet? Stay tuned to find out. The Earth's magnetic field is surrounded in a region which is called the Magnetosphere, and, like an invisible force shield around the Death Star, it prevents most of the particles from the Sun, which is carried by solar winds, from hitting the Earth. This magnetic field reaches an astonishing 36,000 miles into space. We said that the field stops most of the particles from solar winds. However, some particles can enter the Earth's atmosphere from what's called the magnetotail and create a beautiful red to pink, bluish-green, and purple auroras, such as the northern and southern lights. These auroras are created when particles from the Sun become trapped in the Earth's magnetic field. And yes, Earth does have a magnetic tail. It is an extension of the same familiar magnetic field we experience when using a compass to find our way around the Earth's surface. In fact, our entire planet is enveloped in a bubble of magnetism, which is created from a molten dynamo in Earth's core. Out in space, the solar wind presses against this bubble and stretches it, creating a long magnetotail in the downwind direction. This tail stretches out deep into space and even gives the moon a magnetic lashing once a month. Scientists have recently discovered that the Earth's magnetic field was once 10 times weaker than its current values. In fact, it wasn't just weaker, but was on the verge of complete collapse. This period of weakness lasted about 75,000 years. It was found that the Earth's core likely started solidifying around 565 million years ago, in the late Ediacaran period. This event recharged the magnetic field just in the nick of time. Luckily for us and the planet, the inner core started to grow and provided a new energy source for the formation of the Dynamo. This was a very critical point in the evolution of the planet, and if it had not happened during this time, none of us would be here today. In fact, the formation of the core occurred just before the Cambrian explosion, which was a period of enormous evolutionary progress 541 million years ago that resulted in the rapid emergence of animal life. The Earth's core itself is essentially a solid ball of iron-nickel alloy that is as hot as the surface of the Sun, and this nucleus is surrounded by a liquid outer core. As the Earth spins, the molten metal flows, forming electric currents that produce the magnetic fields. And while it would seem logical that the core of the planet is the oldest part, this is just not the case. If you're wondering how scientists figured out that the core is only 565 million years old, they collected samples of feldspar and pyroxene crystals from Ediacaran age rock. Inside these ancient crystals are tiny magnetic needles that have presented the record of the magnetic field at the time when they were first locked away in the mineral. It was also found that the Earth's magnetic field was going haywire and reversing its polarities 20 times faster than it does today. But recently, scientists have found that the magnetic field is behaving erratically and moving and shifting much faster than it should. On January 30th, 2019, the World Magnetic Model, which governs modern navigational systems, was due to undergo an unscheduled update. The current GPS model was expected to remain valid until 2020, but the magnetic pole is shifting so quickly that it needed to be adjusted. In 2018, magnetic north skipped over the international dateline and entered the Eastern Hemisphere. In the last 30 years, the rate of distance that the magnetic North Pole moves per year sped up from 9.3 miles per year to 34 miles per year, moving out of northern Canada, across the Arctic Ocean, and towards Siberia. Of course, the magnetic pole naturally moves, and there have been several pole reversals turning north into south. As the poles shift, the magnetic field weakens. It was once thought that these pole reversals would take several centuries to take place, and fossilized magnetization in rocks indicated a geomagnetic reversal that took place fewer than 100,000 years ago. However, in a new study, an international team of scientists analyzed 16,000 years of geomagnetic history, coded into the atoms of an ancient yellow stalagmite that grew out of a cave in southwestern China between roughly 91,000 and 107,000 years ago. By dating and analyzing the iron-bearing minerals inside the ancient stalagmite, it was found that the planet's magnetic field suddenly flipped polarity in as little as 100 years. That's 30 times faster than the generally expected rate, and 10 times faster than was thought to be the fastest rate possible. These switching of the poles have had a big effect on the magnetic field itself. The Earth's magnetic field is becoming weaker and is rapidly fading. In fact, it is almost 16% weaker since the year 1840. Some scientists think that a big magnetic pole shift is happening right now, and that it will have a major impact on the planet. Researchers have estimated that the planet's magnetic field has already lost 30% of its intensity in the last 3,000 years, and they predict it will drop to near zero in the next few centuries. In fact, the intensity drops about 7% every 100 years. No one is sure what is really going on. The North Pole's erratic movements are largely the result of the Earth's liquid iron outer core, which is known as the core field. Of course, there are other smaller factors that also play a part in its movements, such as magnetic minerals in the crust and upper mantle, as well as electric currents created by the flow of seawater. But the influences from these are small compared to those that are from the core field. It could be possible that something unseen is happening inside the planet because the core field is weakening, which could be a sign that a complete flip is inevitable. It was recently found that the Earth is drinking more water up from the oceans than previously thought, and this could be playing a big part of what is happening inside the planet, causing the magnetic poles to go haywire. If the roving magnetic field keeps moving, it's possible that in 100 years from now, people will see the northern lights in a different place than today. It is also possible that a sudden reversal could bring with it more dire consequences other than just being able to see the auroras in weird places. There isn't anything good about any planet losing its magnetic field. Without a geomagnetic field, human technology would be at risk. Satellites can and already do suffer damage from solar storms. There are currently about 1,100 satellites in orbit around the planet. One by one, each of these satellites, which are protected by the Earth's magnetic field, would be damaged and stop working. Many systems on the planet, including those used for navigation, would fail. You could say goodbye to any GPS system, as they would be rendered useless. There would be global power outages, and many electronic devices would be damaged and become useless. Cosmic rays and solar wind would be extremely harmful to all life on the planet, and the Earth would be constantly bombarded by a stream of deadly particles. The effect of cosmic rays on the human body could be terrifying. Astronauts who were on lunar missions reported seeing flashes of light when their eyes were closed, which would have been the result of cosmic rays passing through their retinas. Some of those astronauts developed cataracts years later from this exposure. These same deadly rays could even damage our DNA, which would increase the risk of cancer and other illnesses. Let's say that the flashes of light with closed eyes would be the least of our problems. About 50 different species of animals use the magnetic field for navigation, and especially birds like the homing pigeon. Without the magnetic field, these animals would basically be blind and unable to orient themselves. Sea turtles would get lost at sea, birds would migrate, creating massive die-offs, and honeybees would be lost trying to find their hives, which would greatly impact the pollination of flowers and plants, those plants in our food crops that the human race relies on. In the end, after all life was extinguished and the last remaining humans moved underground, superstorms, massive electrical storms, and microwaves from cosmic radiation would literally cook the planet, as its atmosphere and oceans would be literally stripped away over time, until there was nothing left but bare rock. The most horrifying effect of losing the Earth's magnetic field would be losing the air we breathe. The sun's natural wind is so powerful that it can easily rip the gases out of a planet's atmosphere until there's nothing left. If you're curious exactly what would happen, then you need to look no further than the barren planet Mars, which some scientists believe was much like the Earth until its weak magnetic field collapsed and its atmosphere, left completely unprotected, caused it to be ripped away into space. Once Mars' atmospheric pressure dropped low enough, the planet's water began to evaporate until it, too, was taken into space by the sun's solar winds. No one is sure when the magnetic poles will flip, and over the course of the Earth's history, the poles have reversed hundreds of times. Some scientists say that the reversal is overdue, and that the core of the Earth is becoming increasingly volatile, and with everything currently happening, it's an indicator that something unusual is definitely happening inside the core. When looking at satellite imagery, it can be seen that part of the magnetic field has already reversed in the southern hemisphere, and is called the South Atlantic Anomaly. Something that the scientists call the reversed flux patch is moving to the west and has doubled in size over the last 60 years, and now covers 20% of the planet's surface. Scientists simply do not have enough information to make any conclusion of what is going to happen, but it's certain that the poles will reverse again at some point. The consequences for life on Earth are potentially devastating, and experts in solar radiation say that parts of the planet will become uninhabitable. This event will affect all creatures on the planet, as well as the effects on our electromagnetic system, the electric grid, and all things considered part of our modern civilization. We hope you enjoyed the video. Please tell us what you would do if the Earth suddenly lost its magnetic field. How would you survive? And if you liked the video, please click subscribe and turn on notifications so that you'll be the first to know when we release a new video. Thank you for watching, and we'll see you next time.